Hello everyone, I'm Yesha. Hope you all are doing well and enhancing your skill as well. So here today I have something interesting for you all, which is connected with artificial intelligence and VLSI domain. So this topic is synchronized with this both domains. So let us see what it is. So I am representing here digital design optimization by minimizing technique from schematic. So let us have first idea about what is called schematic, how it looks like. So here I put one image so that you can get idea about how schematic looks. So schematic is basically made with different kind of logic gates and logic blocks connected with a wire. So you can see from the screen how it looks. Now let's understand about the problem statement, why we are going with this kind of solution, what we are proposing, so which can solve the many problems of VLSI. So AI here will play a big role to resolve this problem in VLSI field. So first we know how schematic looks and what is it. So you can see one schematic here. I put some one simple image, one simple schematic, so you all can understand the behind the purpose of our project. So what we are going to resolve. So here is one schematic which is having two logic AND gate and one OR gate. Okay. So both are denoted as U1 and U2 respectively. So U1 is the output of U1 is logical ANDing between A and B, and output of U2 is logical ANDing between A and negated B. Okay, so those both output will be input as OR gate in the OR gate, and it will give a output which will be our ultimate output of the circuit O, which is AB plus A negation B. Okay, so now let us have how we can simplify it. This schematic, this is another schematic which is shown in the screen, which is we can get by minimizing technique of Boolean algebra from previous schematic. So what was the output of our previous schematic? Was that AB plus A negation B. Okay, so now take a common and we have a B plus negation B. So B plus negation B is ultimately logical ORing between B and the negation of that wire, which will be a logic high output. So we have now O equals to A, which is the only A wire output. So now you get my point that how we can optimize the complex circuit with a simpler way, in a simpler way, right? So this design is more optimized than previous one. So previous design will be replaced with optimized design. So we can, the complex circuit may consume more power, right? And it may take more time to execute the output. So now our optimized circuit will optimize those all the parameters which needs more in the previous complex circuits. Now, here another examples I shown in the slides. So before optimization, it looks like one A, B with all the ending gates, and after optimization, we have only A and B two inputs. You can see that A is applied into three negation, three node gates, which is equivalent to the one node gate, right? So to enhance the simulation efficiency, to minimize the area, to enhance performance, which will also reduce the cost, and it will also reduce the timing delay of the circuit. So this may help us in a various area, right, for our circuit. So this AI, how this AI will gonna support to us, which will show in the next slide. But here the data set is mentioned that we are here using different kind of schematic images from the Google. We're downloading it and we will put it into the database. This is the main flowchart of our design, right? That we first have to upload the digital design schematic. Then we will find the shape of the block, or we can say the block detection from the schematic. Then we should extract the text from it, that what it is actually. Like if there is a 2x1 marks, then we should know that that block what it is representing, right? So it is basically text extraction. Then we will identify the building logic, and then we can optimize the logic and we can replace it. so our circuit will be optimized. Now, here I used opencv shape detection for the shape of the block, right? So here, obviously, this is the core-based algorithm for shape detection, which is counter approximation. Is an algorithm for reducing the number of points in a curve with reduced set of points, right? So this algorithm is commonly known as Ramer-Dulux-Pucker algorithm, which is also said split and merge algorithm. What it do? So it is basically find the points in the uh, different intensity part, and it will join the lines, and it will make a segments of it. So this will be detected as a our block or any shape, right? Yeah, so counter approximation is actually already implemented in opencv via cv2.approx polydp method. Okay, so we will gonna use this method in our program, which I will show in the in next few minutes. And counter approximation is predicted on the assumption that a curve can be approximated by a series of short line segments, right? As I as I have shown you in this GIF, you can see how it is going to predict. Like it will first identify some points, and then it will connect with some segment. So this leads to the resulting approximated curve that consists of a subset of points that were defined by the original curve. Yeah. So here is the result of the simple shape image. The GIF which you are which you have seen in the screen, which is the output of the shape image. Like this image is consisting different kind of shape like pentagon, circle, square, triangle, rectangle, many more. So it will identify, it will mark as a green line around it, and it will have a tagline that what is the label of the shape, right? You can see like in the square it is labeled as a square, and triangle, and many more. Yeah, so this is the result for different schematics. I would like to show you now the code, then we will go with this. Yeah, so this is our main fundamental coding for this shape detection. So here I'm just importing some libraries which is needed. Yeah, so as I said that those are the libraries which are needed to implement our functions. So we first importing this. I'm here using Google Colab because it's portable. We can use and we can edit anywhere. And then this is a shape detector class which will define the shape of the block on the basis of the counters. Okay, so if it's a 3 counter, then it's obviously the shape of the triangle, right? If it's 4, then there are two possibilities on the basis of the length of the counter slide. Okay, so if it's equal length of size, then it should be square, right? And if it's different, then it must be a rectangle. And if the counters are 5, we find the 5 counters, then it is pentagon, otherwise it's circle. Okay, so let us run this. Yeah, so here I am importing image from the my Google Drive. So first we need to import the drive from the Google Colab, and we are mounting data from the drive. Right. It's already mounted because I already run it before. This we are changing the path. Now we are reading the image which is in the folder of AI, and the name of image is im2 png. We are here doing a pre-processing of the image, like we are converting into a grayscale image, and we blur other area from the object. Okay, this is for finding the contours which will be based on the shape, right? If it's triangle, then it will be 3. If it's square or rectangle, it will be 4, like that. So here on the count of contours, we are having one loop which will show which will draw the counters and which will put the text over it with a label of the shape, right? So here I am gonna show you the output in a while. Due to some uh, connectivity, it's not responding, it takes time. So yeah, so this is now loaded. So yeah, it gives output such as displayed in the screen. So it gives output. This is the basic image which we loaded, and it is having three blocks of rectangle, right? Four rectangles are shown in the image. So we need to detect four block as a rectangle. So when you are scrolling down, it will give you the final result. You can see here there are four rectangles are labeled here, and there are some different kind of label are put it in here, that is pentagon, triangle, which is because of this line. Okay, you can see this line is also having different contours which is detected by this algorithm. So we will discuss about it, that why it is detecting, and what will be the another solution for it. So now let us go again with presentation. Yeah, so you can see now that this image is also applied, and I got the result as if different kind of label are also there, that pentagon and rectangle, triangle also, but it is not detected successfully, as you can see, because the background should be black and the all the here text is also fulfilled with the colors. Okay, so this is not included here. That's why it's predicting wrong. Yeah, this is the another result. This is a basic circuit which is applied, which is image is loaded, and the output is like this. Yeah, so we were talking about this. So this image is also loaded, and we got the output like this. In that, you can see there are many labeled are here as a pentagon because of this wires. See, you have to remove that wires also. Then and then it will recognize the shape perfectly. Okay. So here is the last image which I demonstrated you, that this is recognized successfully as a rectangle for rectangles. Yeah. So what are challenges which I faced, which is mainly because of that interconnection, which I already told you about this, like those interconnects having a contours and it recognizes the pentagonal more larger shapes. So due to that, the shape is detected wrongly, and it has a less accuracy because of the we are using custom image, right? We are not using here data set. I have applied one image at a time, so due to that, we are getting less accuracy, and there's no data set. Afterwards, I will plan to have a data set, and also after this I need to extract the text, as we see, as we have seen in the flowchart, that after detecting the shape we need to extract the text, and then we can build a logic and we can optimize it, right? So this is the first part of this project, that we detected the shape of the block, logic block. Yeah, so we will see the next process in the next video. Thank you very much.